Hello everyone and welcome to this video. The lesson in this video is about the types of numbers, HCF, LCM, and prime factorization. This video covers types of number, reciprocal, factors, common factors, HCF, multiples, common multiples, LCM, and prime factorization. Let us look at the very first type of numbers, whole number. So what is a whole number? A whole number is any number from 0 to infinity with no fractional or decimal part. So examples of whole numbers. So it starts from 0, 1, 2, 3, 4, 5, and so on. With no fractional or decimal part, all positive numbers. Natural number is any whole number from 1 to infinity. So these numbers are used for counting. So because they are used for counting, so that's why 0 is not included. So natural numbers, examples of natural number include 1, 2, 3, 4, 5, and so on. An even number is a whole number that can be divided exactly by 2. So examples. So even number starts from 2, 4, 6, 8, 10, and so on. So all these numbers are divisible by 2. An odd number is a whole number that cannot be divided exactly by 2. So examples include 1, 3, 5, 7, 9, and so on. So all these numbers are not divisible by 2. What is a prime number? A prime number is a whole number greater than 1 which has only 2 factors: the number itself and 1. So take a look at number 2, okay? A number. So the very first prime number is 2. So 2, it can be written as 1 multiplied by 2 only. So can you see? There are 2 factors, which is 1, and the number itself 2. So the next prime number will be 3. So I can express it as only 1 multiplied by 3. So only 2 factors. So 3 is a prime number. How about 4? It can be expressed as 1 multiplied by 4. And also 2 multiplied by 2. So in total, there are 3 factors. So therefore, we conclude that 4 is not a prime number. Four is not a prime number because it has 3 factors. A prime number has only 2 factors. So 2 is a prime number, 3 is a prime number. The next prime number will be 5, followed by 7, followed by 11, followed by 13, and so on. So all these are examples of prime numbers. One is not a prime number because it has only one factor. So I can express it as just 1 multiplied by 1. So can you see? Only one factor. Only one factor. So that's why 1 is not a prime number. An integer is any of the negative and positive whole numbers, including 0. So there are 3 types. Positive integers, negative integers, and 0. So 0 will be just 0. So positive integers, example 1, 2, 3, 4, 5. Negative integers, here are some examples. A square number is the product obtained when an integer is multiplied by itself. Okay, the very first integer, positive integer, is 1. So 1 multiplied by 1 multiplied by itself. Okay, 1 multiplied by 1 is 1. 2 multiplied by 2 will be 4. So 1 and 4 are square numbers. 3 multiplied by 3 is 9. So 1, 4, and 9 are square numbers. Okay, I can rewrite this as 1 square, 2 square, 3 square. So square numbers, the next square number will be 4 multiplied by 4, which is 16. 5 multiplied by 5, 25, or 5 square, 25. 6 square, 36. 7 square, 49, and so on. So all these are examples of square numbers. Cube number is the product obtained when an integer is multiplied by itself and then multiplied by itself again. So 1 multiplied by 1 multiplied by 1, or 1 cubed, is equals to 1. 2 cubed, 2 cubed, 2 multiplied by 2 multiplied by 2, 8. Okay, so 1 and 8 are cube numbers. So the next cube number, 3 cubed, 3 multiplied by 3, 27. So 4 cubed will be 64, the next cube number. 5 cubed, 125, and so on. So all these are cube numbers. Real numbers can be divided into two: rational number and irrational number. Rational number can be written as a fraction. It can be an integer. So examples: so negative number, positive integer, mixed number. Okay, mixed number is also a rational number. Decimal. improper fraction, and recurring decimal. So 0.3 with a dot above the 3 is equal to 0.333. Okay, 333. The list is endless, 3333333. So if I change it to fraction, it is 1/3. So recurring decimal is also a rational number. An irrational number cannot be written as a fraction. So examples of irrational number include square root of 3. If you press from your calculator, you'll get 1.732 and you have many digits behind. So if you try to change it to fraction, it's not possible, even with the aid of a calculator. Maybe cube root of 2, also you cannot change to fraction. Pi also you cannot change to fraction. So these are irrational numbers. What are reciprocals? The reciprocal of the number n is 1/n. So let's say if I mention, okay, if I say the reciprocal of 3, the reciprocal of 3 will be 1/3. The reciprocal of 11 will be 1/11. As simple as that. The reciprocal of the fraction a/b is b/a. For example, reciprocal of 2/3 is 3/2. So why? Because reciprocal of 2/3 is actually 1/2/3. So if I change to divide, so once I switch to multiply, it will be 3/2. So how to list factors? For example, factors of 30. So I can write it as 1 multiplied by 30, 2 multiplied by 15. I will get 30 also. 3 multiplied by 10. So 30 is indivisible by 4. So I proceed to 5. 5 times 6. So these are factors of 30. So in total, there are 8 factors. Eight factors. Okay, so factors must be whole numbers. So you cannot have decimal. So the number listed here are whole numbers also. So factors must be whole number. So 30, we have 8 factors of 30. So how about 45? So let us list all the factors of 45. So start with 1 multiplied by 45. So 45 is indivisible by 2. So I skip to 3. 3 times 15. 45 is indivisible by 4. So the next will be 5. So 5 times 9. Okay, that's all. So 6 factors in total. In total, there are 6 factors of 45. So how to get prime factors of 30? So you pick from the list. You pick prime numbers. So 1 is not a prime number. So 2 is a prime factor of 30. 3 is also a prime factor of 30. And 5. No more. How about prime factors of 45? So it will be only 3 and 5. So how to get common factors of 30 and 45? So you have to get from the list just now. So common means the same number appear in both lists. So it will be 1 appear right twice. Next will be 3, 5, 15. So 4 common factors. 1, 3, 5, 15. 1, 3, 5, and 15. Highest common factor, it will be the highest one, which is 15. So let's say if we want to find lowest common factor, it will always be 1. For any pairs of numbers, okay, it will always be 1. So that's why in question, you will never be asked to find lowest common factor because the answer is always 1. So the method just now, okay, to obtain highest common factor was by listing. Okay, so we list all the factors and then we pick the highest common factor. Okay, but there's an alternative method to find HCF, which is through continuous division. Okay, division. So how to do that? So let's say if we want to find HCF of 30 and 45 by division. So first you pick a number. You choose a whole number, any whole number that divides exactly into both of them. So meaning that that number, okay, 30 and 45 must be divisible by that number. So that's the first step. So you choose a whole number that divides exactly into both of them. So 3, we start with 3. Because 30 and 45 are divisible by 3. So 30 divided by 3, it will be 10. 45 divided by 3, 15. So 10 and 15 are divisible by 5. So the next number will be 5. So you cannot divide further because you cannot pick a number. Okay, so 2 and 3 cannot be divided. Okay, so there's no number that divides exactly into 2 and 3. So we stop here. And HCF will be just the product of this. Okay, so 15. Find the HCF of 48 and 64. Okay, so following the same procedure. So both 48 and 64 are divisible by 2. (24) and 32 are divisible by 2. (12) and 16 are still divisible by 2. So you continue. So you cannot divide further. So HCF will be you just multiply 2 multiply 2 multiply 2 multiply by 2, 16. So you may ask, can I choose any other numbers? Okay, the answer is yes. So maybe I want to divide by 4, because 48 and 64 are divisible by 4 also. Okay, you can do that. So HCF will be 4 multiplied by 4. So can you see the same answer? So you can choose any whole number as long as 40 and 64 are divisible by that number. How about 3 numbers? Find the HCF of 24, 36, and 60. So the same way. So you pick a whole number, any whole number, that divides exactly into these 3 numbers, 24, 36, and 60. So 24, 36, and 60 are divisible by 2. These 3 numbers are divisible by 2, still divisible by 2. And then you divide by 3. 6, 9, and 15 are divisible by 3, obviously. So you cannot proceed anymore. So it will be 12. Another example. You may pause this video and try it. So that's all for HCF. How about multiples? So let's say if I want to list the first 10 multiples of 30. So it will be like this. So I'll start with 30. 30 plus 30, 60. 60 plus 30, 90. 90 plus 30, 120. So you continue the list until the 10th term. So for 45, similar way. So these are multiples. Okay, so 30, 60, 90 until 300 are multiples of 30. 45, 90, 135 until 450 are multiples of 45. So the list is endless. So that's why usually you'll be asked to list the first 10 multiples. So you only need to list until the 10th. So how to get common multiples? So again, you pick the number that appears in both lists. So 90, 180, and 270. Lowest common multiple, obviously, is 90. So you can get lowest common multiple by listing the multiples of 30 and 45. Okay, but this is time consuming process, is a time consuming process. So there's an alternative way. But before that, so usually you'll be asked to find lowest common multiple. So if you talk about highest common multiple, obviously no answer. So no HCM. So why no highest common multiple? The reason is because the multiple list is endless. So you can list until very huge numbers. Okay, so it's endless. Okay, it's continuously. So you cannot get the highest common multiple. You can only get the lowest common multiple. Okay, so let us look at alternative method on how to find LCM. So the initial process is the same as finding HCF. So let's say if I want to find LCM of 30 and 45. So initially the process is the same as HCF. So you pick a number, a whole number, any whole number that divides exactly into these two, 30 and 45. So 3, 30 and 45 are divisible by 3. 10 and 15 are divisible by 5. Okay, HCF, we stop here for HCF. But for LCM, we proceed. We continue the division. So I can just divide by 2. 2 divided by 2, I'll get 1. 3 is not divisible by 2. So we'll just remain as 3 here. And then I'll divide by 3. So to get LCM, I have to multiply all the numbers here. So generally the process is the same as HCF, but you continue the division until you get 1, 1 in the end. So let us try LCM of 72 and 108. So the initial process is exactly the same as HCF. So 72 and 108 are divisible by 4. Okay, you divide first. 18 and 27 are divisible by 9. Okay, so if you are finding HCF, you stop here. You stop here. But for LCM, you continue the division until you get 1, 1. So you just multiply to get your LCM. How about 3 numbers? So the same process. So 25, 35, and 45 are divisible by 5. Again, if you are finding HCF, you stop here. But if you are finding LCM, okay, if you are finding HCF, you stop here. If you are finding LCM, you continue the division until you get 1, 1, 1. So this will be my LCM. Another example, you may pause this video to try on your own. That's all for LCM. So the last part of this video will be about prime factorization. So how to do prime factorization. So example, if I want to express 630 as a product of prime factors, so very easy, you just continue divide 630 by prime numbers. So let's do it systematically. The very first prime number is 2. So divide by 2. So 630 divided by 2, you will get 315. So 315 is not divisible by 2. So we proceed to the next prime number, which is 3. 315 divided by 3, 105. So 105 is still divisible by 3. So 35 is not divisible by 3, so we proceed to the next prime number, 5. Okay, and then 7. So 630 is 2 multiplied by 3, multiplied by 3, multiplied by 5, multiplied by 7. So I can rewrite it as 2 multiplied by 3 square. 3 times 3 is 3 square. So this will be your final answer. Express 1001 as a product of prime factors, so similar. So you just need to divide by prime numbers. Okay, so all these are prime numbers, so prime numbers only. Okay, prime numbers only will be used. Okay, so same way of doing it. So 1001, 7 multiplied by 11 multiplied by 13. So that would be your final answer. That's all. Thanks for watching. Please like and subscribe for more videos.